Now that we've seen how to find a derivative using a four-step process, that's very cool, but those problems can be time-consuming and long, and it's easy to make a mistake in them. So in this section, we're going to see if we can speed up that process, maybe make it a little bit faster for us so that we don't have to rely on that four-step process every single time. Before we jump into that, though, I just want to talk a little bit about notation. If we are working with a function y equals f of x, f prime of x, y prime, and dy over dx all represent the derivative of f, and they're all talking about that same derivative. So even though these might look different or have different names, they're all still just talking about the derivative. We were pretty used to seeing f prime of x in the last section, but we may see y prime instead. It's pretty similar to f prime of x. And this guy over here, this has dy over dx, which kind of means the derivative of y with respect to x. That's actually my preferred way to write the derivative, but in our class, we're primarily going to be using f prime of x and y prime. So we're going to think about the most basic case of functions, start with the easiest possible scenario, but before we even do that, I want to just remember that the derivative of a function can tell us the slope of the tangent line, because this is how we're going to come up with our first shortcut here. So we're going to start with the most basic function here, which is a constant function. It says f of x equals c. And just so that we have a concrete example to work with, let's work with f of x equals 3. Now, if I were to sketch that function, let's see, I've got 1, 2, 3. If I were to sketch the graph of this function, let me do that in blue right here, I would see a horizontal line that looks like this. Now, I want to utilize this fact right here, the fact that the derivative of a function can tell us the slope of the tangent line. Now, if I had chosen to sketch in the tangent line, let's say right here at this particular x value, if I were to draw in my tangent line, it might seem kind of silly because I'm already working with a line, but my tangent line would just fall right on top of that other line, on top of the function. Well, I want to think about what's the slope of this tangent line, because that might give me a clue to the derivative. Well, here I have a horizontal line. We said in the last section that the slope of a horizontal line is 0. So, okay, that's one possibility, but I want to see if maybe if I draw the tangent line somewhere else, maybe if I take a different x value. What if I take one over here? Maybe I work with a negative x value. And if I were to sketch in the tangent line, well, once again, I'm just working with a line, so that tangent line would fall right on top of my function. And I'd say, okay, well, the slope of that line, once again, we have a horizontal line, the slope of that line is 0. Let's try one more time just to see what's going on here. Let's pick a different x value. Let's try 0. Let's draw the tangent line right here. Well, the tangent line would once again just sit right on top of my function. It would just be another horizontal line. Horizontal lines have a slope of 0. So no matter what x value we pick, the slope of that tangent line is always going to be 0. And this is not just specific to x equals 3. This is true for any constant. If I were to take, let's take a negative number. So let's draw in another constant function. Let's draw it down here. Let's say a negative number. I'm not even going to say what this constant is, but if I wanted to draw a tangent line at any x value, let's say right here, well, that horizontal line, my tangent line is going to sit right on top of my horizontal line, and I know that the slope of that is 0. So this kind of leads us to our first shortcut here. If we're working with a function, a constant function, if we're working with f of x equals c, then the derivative of that function, f prime of x, will always be 0. So this is our first shortcut for derivatives that we have for today, and it's a really nice one. It's really easy to remember. If you're taking the derivative of a constant, it's going to be 0. It doesn't matter what that constant looks like, whether it's positive or negative, whether it's a whole number or a fraction or a decimal, big number, small number, derivative of all of those is going to be 0. So just a couple quick examples here before we wrap up this video. If I want to find the derivative of each one of these functions, if I'm working with, say, f of x equals negative 24, well, if I wanted the derivative of that, this is a constant. And really what I mean by a constant is it doesn't depend on our variable x in any way. If we look over here, there is no variable x. It's just equal to negative 24. So no matter what x value I plug in, I'm always going to get back negative 24. So that's how I know that this is a constant function. So I can look at this, I say, well, there's no variable of x right here. This must be a constant function, so its derivative, f prime of x, must be 0. And there we go. There is our derivative. We don't really need to show any work there. Next up, I've got g of x equals pi. Remember that pi, even though it might look like a variable, it looks like that symbol, but remember that pi, it's 3.14159, blah, blah, blah. I forget what comes after that, but it's a constant. It's a decimal. It's technically a decimal that never ends. It's an infinite decimal that does not repeat itself, but it's still just a constant. It doesn't depend on x in any way. So if I want to take the derivative of this function, if I want to take the derivative of g of x, g prime of x in this case is just 0. And I don't have to show any work. There's my derivative. Lastly, for y equals 0, this one might look a little bit tricky right here. If I'm working with y equals 0, once again I see, well, this doesn't depend on my variable x in any way, and 0, even though it's a special number, it's still just a number. It's still just a constant. So when I take the derivative of 0, y prime, or if you prefer the notation dy over dx, the derivative of that function is still just going to be 0. So even though I start with 0, my derivative is still just going to be 0 in this case. So this is a really nice property to have. It allows us to just take the derivative of any constant function and just say that the derivative is 0. Now, of course, not all the functions that we work with are going to be constant functions. We have to work with more interesting functions. So in the next video, we're going to start to explore what happens when we do add that variable of x in.